Dictionary view objects. The objects returned by dict.keys, dict.values, dict.items are view objects. They provide a dynamic view on the dictionary's entries, which means that when the dictionary changes, the view reflects these changes. Dictionary views can be iterated over to yield their respective data and support membership tests. Length of dict view return the number of entries in the dictionary. ITER dict view return an iterator over the keys, values, items represented as tuples of key value in the dictionary. Keys and values are iterated over in insertion order. This allows the creation of value, key pairs using zip pairs is equal to zip d values, d keys. Another way to create the same list is pairs is equal to v, k tuple for tuple k v in d dot items. Iterating views while adding or deleting entries in the dictionary may raise runtime error or fail to iterate over all entries. Changed in version 3.7, dictionary order is guaranteed to be insertion order. X in dict view return true if X is in the underlying dictionary's keys, values or items. In the latter case, X should be a key value tuple. Reversed dict view return a reverse iterator over the keys, values or items of the dictionary. The view will be iterated in reverse order of the insertion. Changed in version 3.8, dictionary views are now reversible. Dict_view.mapping return a types.mapping proxy type that wraps the original dictionary to which the view refers. New in version 3.10, keys views are set like since their entries are unique and hashable. Items views also have set like operations since the key value pair are unique and the keys are hashable. If all values in an item's view are hashable as well, then the item view can interoperate with other sets. Values views are not treated as set like since the entries are generally not unique. For set like views, all of the operations defined for the abstract base class collections.abc.set are available. For example, equal, less than, and XOR. While using set operators, set like views accept any iterable as the other operand, unlike sets which only accepts sets as the input. An example of dictionary view usage. This is let's okay okay let's try to run the program. This is a dictionary initialization, and keys is equal to this dot keys, values is equal to this iteration, n is equal to 0 for val in values, n plus is equal to value, print n. 504, that is true. Now list keys will list all keys. Print list keys will print all keys. Right, and list values will print all values. And then view objects are dynamic and reflect disk changes. Delete this is now delete this is eggs and sausage and print lid, bacon and sperm, and then set operations, keys and intersection. So only bacon, print set operation. So x is not present here. Okay, now x present, bacon present, salad is not present, x and bacon, right? And XOR operation, XOR operation. So x is present, sausage is present here, yes, so it will not be there. Juice, yes, so equal to juice, sausage, bacon, sperm, then bacon, sperm, yes, correct. False, why? Yeah, because this is only eggs and juice. Let me do like eggs and juice. Let me return this one. Why? Sausage, eggs, keys, eggs, so eggs will be there, sausage will not be there, bacon will be there because it is present in only one dictionary, and juice, yes, juice will be there because it is only present in one juice, and then sperm, sperm, right? True, yeah, this is correct because this is the same set as this one. Right, you need to know XOR operation. So this one is OR, and get back a read-only proxy for the original dictionary. Values dot mappings, let's see. Print values dot mapping, run x2, sausage 1, bacon 1, sperm 1, right? And values dot mapping sperm, print values dot mapping sperm is 500, correct? Thank you.